Dan Cooper acquired a Maytag washer in 1972. He confirmed 54 years on, the machine is still functional. Yet, a new $3,000 smart refrigerator often fails in under 5 years. Why do we go from lifelong machines to disposable? When it inevitably fails, repair technicians won't fix it. They will simply instruct you to dispose of the entire unit. This investigation will expose the engineering flaws concealed within your kitchen and laundry appliances. We'll examine the linear compressor fraud and sealed bearing catastrophe. Also, the computer chip scheme, making home appliances disposable. We start with refrigerators, focusing on a specific design. It's a component called the linear compressor. Refrigerators long utilized a standard rotary compressor design, a simple motor rotated within an oil-filled chamber for lubrication. Loud and less energy efficient, these were nearly impossible to break. However, in the early 2000s, LG and Kenmore chose to innovate. New energy mandates led them to create the linear compressor. Unlike rotary models, this motor reciprocates a piston, like a syringe. They promised energy savings and reduced noise levels. However, a critical engineering flaw emerged. Lacking rotation, it cannot circulate oil to lubricate internally. Instead, it depends on complex valves and springs to prevent friction. These valves often fail, as proven by a massive class action suit. Should a linear compressor fail, metal fragments will clog your fridge's cooling system. The appliance suffers an irreparable internal system failure. Replacing just the compressor is impossible. Its circulatory system fills with shrapnel. Your fridge is destroyed. Yet, even if the compressor holds up, a different design fault plagues your current refrigerator. We're talking about the ice maker. Owners of Samsung French door ice makers traditionally stayed within the freezer's cold confines. It logically followed, given freezers naturally stay frozen. Contemporary buyers craved additional shelving capacity. They are challenging thermodynamic principles directly. Water freezing occurs in a compartment meant for 38-degree food. Engineers must force cold air up through flimsy tubes into a poorly insulated section. An unavoidable conclusion is reached. Leaky seals allow warm air in, causing ice makers to freeze solid. Consequently, it seizes. Water spills onto your floor, ultimately destroying the fan motor. This system battles physical laws just for a minimal cosmetic improvement. Computer chip integration is the next culprit for appliance failure. Older ovens featured a simple, hand-operated control dial. This fundamental switch delivered power directly to a heating coil. If it malfunctioned, a $10 replacement. Today's ovens feature complex motherboards with tiny microprocessors. Manufacturers position this fragile circuitry right by the oven vent. Heat-sensitive computers are installed within heat-generating appliances. Recurrent heat cycles fracture board solder points. Yet, the self-clean mode, sold as a premium, is the real destroyer. Activating self-clean locks the oven, raising its temperature to 900 F. This extreme warmth ascends the range, severely damaging the control board. Repair professionals consistently report this finding. Engaging self-clean quickly kills contemporary ovens. You're essentially destroying its core to avoid 10 minutes of cleaning. The control board replacement typically costs $400 if produced. The identical reasoning holds true for contemporary dishwashers. Older 1990 dishwashers were notably noisy appliances. Its sound resembled an aircraft engine. That sound indicated a robust motor actively pulverizing food scraps. Cycles took 45 minutes, delivering impeccably sanitized dishes. Current regulations force dishwashers to employ small, underpowered pumps. They only spray moisture across your plates. For thorough cleaning, the unit requires 3 or 4 hours of operation. With insufficient motor power for grinding, the disposal component was eliminated. Instead, you're tasked with manually clearing a mesh filter basket inside the tub. So you must personally scoop out disgusting, wet food debris. You pay more for an appliance that's slower and demands your labor. The most egregious design flaw, however, is the sealed tub. It's why modern washers have become mere throwaway units. Older Maytags, like the 1972 model, used metal drums on bearings. Bearings inevitably degrade from constant operational strain. With older machines, replacing worn bearings was a $20 fix. This would grant you an additional 10 years of service. But brands like Whirlpool and Samsung now employ plastic fusion. They integrate bearings into the plastic outer tub, sealing them permanently. If that $20 bearing breaks, its replacement becomes impossible. The complete tub unit needs swapping out. The part itself is $400, with an additional $300 for labor. This means a $700 fix on an appliance worth $800. The repair professional utters our modern economic mantra. This isn't economically viable to repair. This isn't an accidental flaw, but a deliberate design decision. Manufacturers deliberately hinder repair. What, then, is our practical answer? Viewers of our previous video recall Speed Queen. A $2,000 washing machine isn't feasible for all budgets. Opt instead for entirely dumb home appliances. When buying a fridge, choose the least expensive, non-smart option. Seek models devoid of touchscreens, integrated ice makers, or Wi-Fi connectivity. Minimal features equate to fewer potential breakdowns. Better yet, follow the financially astute.